Hello, grade 7 learners, parents, and home tutors. I'm your math teacher, Teacher Just, at your service. In this video, we'll have review questions about radicals and performing operations on rational numbers. Are you excited? Let's begin. The first question is, how would you describe the principal root of square root of 16? Is it A, decimal, B, irrational, C, rational, D, mixed number? Try to answer this one in 5 seconds. Timer starts now. Okay, time is up. And what is your answer? If your answer is letter C, then you are correct. Here is now the explanation. Why is it that the answer is rational? Since square root of 16 is equal to positive 4 and negative 4. And remember that the principal root is the positive root based on our previous video tutorial. So, the principal root positive 4 can be expressed in the form a over b, and that is equal to 4 over 1, meaning it is a rational number. Another clue is, if your radicand is a perfect square, then when you extract its square root, its principal root is a rational number. However, if you're asked a question like this, how would you describe the principal root of square root of 15? Observe that the radicand 15 is not a perfect square. So there is no exact number that when you multiply it to itself is equal to 15. So therefore, the principal root of square root of 15 is irrational. Okay? Let's now proceed to number 2. Which of the following is an irrational number? The choices are A, square root of 64, B, 12.02, C, 0.333 repeating, or D, 1.23459, and so on. I'll give you 5 seconds to answer. Timer starts now. Time is up. What is your answer? If your answer is letter D, then you are correct. Here is now the explanation. 1.23459 and so on is an irrational number since it's the only non-repeating and non-terminating decimal among the choices. Okay, why is it not letter A? Because square root of 64 is equal to positive 8 and negative 8. And notice that 64 is a perfect square. So meaning it is a rational number. How about letter B? Letter B, 12.02, is an example of a terminating decimal because its decimal part stops at the hundredths place. So this is an example of a rational number. How about letter C? 0.333 repeating. This is also an example of a rational number because though it is non-terminating, but its decimal part here, which is 3, is being repeated. So this can be expressed in a fraction form. And the equivalent fraction form of 0.333 repeating is equal to 1/3. And for letter D, 1.23459 and so on, this cannot be expressed in a fraction form. So this is classified as irrational number. Okay, let's proceed to number 3. Which of the following real numbers is irrational? The choices are A. Square root of 11, B. Square root of 100, C. Square root of 81, D. Square root of 25. I'll give you 5 seconds to answer. Timer starts now. Time is up. What is your answer? The correct answer is letter A, square root of 11. Because 11 is the only number in the choices which is not a perfect square. Take a look at letter B, square root of 100. 100 is a perfect square because there is a number that when you multiply it to itself is equal to 100. Right? What is that number? It's 10 because 10 times 10 is equal to 100. How about letter C? Square root of 81. Is there any number that when you multiply it to itself is equal to 81? What is that number? Yes, you're right. It's 9. 9 times 9 is equal to 81. So therefore 81 is a perfect square. How about letter D? 25. What is that number that when you multiply it to itself is equal to 25? Yes, you're right. It's 5. How about this letter A? 11. Is there any number that when you multiply it to itself is equal to 11? Okay, there is no number that when you multiply it to itself is equal to 11. So therefore, 11 is, square root of 11 is an irrational number. Let's have number 4. Which of the following statements is false? Is it A, fractions are rational? B, non-repeating and non-terminating decimals are rational? C, terminating decimals are rational? Or D, repeating and non-terminating decimals are rational? Timer starts now. Okay, and the correct answer is letter B, non-repeating and non-terminating decimals are rational. To make this one true, it should be non-repeating and non-terminating decimals are irrational. And the rest of the statements, statement letter A, fractions are rational. Yes, it's true. Letter C, terminating decimals are rational. Yes, it's true. And letter D, repeating and non-terminating decimals are rational. Still, it's true. Okay, number 5. What do you call a number that is non-terminating and non-repeating decimal? Is it A, imaginary number, B, radicals, C, irrational, D, rational? I'll give you 5 seconds. Okay, what is your answer? The correct answer is irrational. Number 6. Between what two consecutive integers the square root of 13 lies? Is it A, 2 and 3, B, 3 and 4, C, 4 and 5, D, 5 and 6? Try this one in 5 seconds. Timer starts now. Alright, what is your answer? The correct answer is letter B, 3 and 4. Here is now the explanation. Here are the perfect squares from 1. 1 squared is equal to 1. 2 squared is equal to 4, 3 squared is equal to 9, 4 squared is equal to 16. Let us determine where is 13. So it's between 9 and 16. So we have here numbers between 9 and 16. So we have here 10, 11, 12, 13, 14, and 15. So it's in between 9 and 16, and square root of 9 is equal to 3, and square root of 16 is equal to 4. Therefore, it lies between 3 and 4. Question number 7. Between what two consecutive integers the square root of 120 lies? Is it A, 10 and 11, B, 11 and 12, C, 13 and 14, D, 15 and 16? Timer starts now. Okay, so what is your answer? The correct answer is letter A, 10 and 11. Why is it 10 and 11? So we have here the following perfect squares. 8 squared is 64. So we'll proceed. 9 squared equals 81. Proceed to 10 squared equals 100. 11 squared is 121. So our target is 120. It's in between 100 and 121. And square root of 100 is 10. Square root of 121 is 11. That is why it is between 10 and 11. Number 8. What is the approximate value of square root of 5 to the nearest hundredths? Is it A, 2.23, B, 2.24, C, 2.25, D, 2.26? I'll give you 5 seconds to answer this one. Timer starts now. Okay, what is your answer? The correct answer is 2.24. So how did we get 2.24? First is you have to determine which two consecutive integers the square root of 5 lies. So we have here 1 squared equals 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. We'll find where is 5. 5 is between 4 and 9. So therefore, it lies between 2 and 3. So it means that the square root of 5 is between 2 and 3. So we'll continue to this step. So remember that the numbers between 2 and 3 there are decimal numbers between 2 and 3. We have 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9, and then before 3. So we'll begin with 2.5 so that if the result is greater than 5, then we will go down. We will go lower than 2.5. However, if the result is lesser than 5, then we will go higher number. So meaning we'll have 2.6 or more. So in this case, we'll have 2.5. 2.5 squared means 2.5 times 2.5. If you'll multiply 2.5 by itself, the answer is 6.25. 2.4 times 2.4 is equal to 5.76, still greater than 5. So we'll go lower. So 2.3 times 2.3 is equal to 5.29, still bigger than 5. So we'll go lower. 2.2 times 2.2 is equal to 4.84. So Observe that 4.84 is lesser than 5. So meaning we will stop at 2.2. So meaning square root of 5 lies between 2.2 and 2.3. But will not stop here because it is asked in the problem that we will approximate the value of square root of 5 to the nearest hundredths. So we will have the numbers from between 2.2 and 2.3. So there are numbers between 2.2 and 2.3. We have 2.21, 2.22, 2.23, 2.24, 2.25, 2.26, 2.27, 2.28, and 2.29. But the technique that I suggest is we will start at the middle part so that we will know if we will go down with the smaller number or will go up with the larger number. So let's try 2.25 squared, that's 5.0625, and 2.25 squared has a result greater than 5. So we'll go lower, so that's 2.24 squared is 5.0176. That is still greater than 5. So we will go lower than 2.24, that is 2.23. And the result of 2.23 squared is 4.9729. So meaning this 4.9721 is lesser than 5. So it lies between 2.24 and 2.23. And this time, we will determine which is the number which is nearer to 5. So what do you think is nearer? Is it 5.0176 or 4.9729? So, as what you can notice, this 5.0176 is nearer to 5. Therefore, the approximate value of square root of 5 to the nearest hundredths is 2.24. Number 9. Find two rational numbers with two decimal places between which the square root of 14 lies. Is it A, 3.74 and 3.75, B, 3.72 and 3.71, C, 3.70 and 3.71, letter D, 3.69 and 3.70. I'll give you 5 seconds. Timer starts now. Okay, what is your answer? The correct answer is letter A, 3.74 and 3.75. Let's try to check why is it the answer is 3.74 and 3.75. So we have here the first 4 perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So 14 is between 9 and 16. So we have here the square root of 9 is 3, the square root of 16 is 4, meaning the square root of 14 is in between 3 and 4. So what our target is with 2 decimal places. So we'll stop at the hundredths place. So we know that there are numbers between 3 and 4. So the numbers between 3 and 4 are 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, and 3.9. So we'll try those numbers, but I suggest that we will start at the middle part, so that when the result is bigger than the target, which is 14, we can directly say that we will use the lower number. However, if the result is lesser than our target, which is 14, we will use the bigger number. So in this case, we started at the middle part, which is 3.5. So 3.5 times 3.5 is equal to 12.25. And 3.6 times 3.6 is equal to 12.96. In this case, we use 3.6 after 3.5 because the result in multiplying 3.5 by 3.5 is 12.25, which is lesser than 14. So that's why we use the next number, 3.6. So 3.6 times 3.6, still 12.96 is lesser than 14. So we'll use the bigger number. 3.7 times 3.7 is 13.69. Still lesser than 14. So we'll use the bigger number, 3.8 squared. So 3.8 times 3.8 is 14.44. This time, this 14.44 is bigger than our target, which is 14. So therefore, it lies between 3.7 and 3.8. So still, we have to move to next step, which is we will use the hundredths place. So there are numbers between 3.7 and 3.8. Remember, the 3.7 is just equal to 3.70 and 3.8 is just equal to 3.80. So between 3.70 and 3.80 we have numbers 3.71, 3.72, 3.73, 3.74, 3.75, 3.76, 3.77, 3.78, and 3.79. But we will start at the middle part, which is 3.75. So 3.75 times 3.75 is equal to 14.0625. So it is bigger than 14. So we'll use the lesser number, 3.74. So 3.74 times 3.74 is equal to 13.9876. So, meaning it lies between 3.75 and 3.74. Since we'll stop at 3.74 because our result is lesser than 14. So if it's lesser than our target, then we will now stop. Okay, so that's why the answer for number 9 is letter A, 3.74 and 3.75. Okay, let's now proceed to question number 10. What is the equivalent fraction form of 0.55 repeating? Is it A, 1/2, B, 5/9, C, 5/10, or D, 1/20? I'll give you 5 seconds. Timer starts now. Alright, what is the answer? The correct answer is 5/9. How did we get the answer? So here is the solution. Let R be equal to 0.55 repeating. This is now the given. Since there is only one repeated digit, and that is 5, multiply the first equation by 10. So we'll multiply 1 times 10, so that is 10R, and multiply 0.55 repeating by 10, so that's 5.55 repeating. Then subtract the first equation from the second and obtain the first equation is R is equal to 0.55 repeating. And the first equation is 10r is equal to 5.55 repeating. So if we're going to subtract 10, this is automatically this is 1. Okay, there's a numerical coefficient 1 here, equals 0.555 repeating. So if we'll subtract 10 minus 1 equals 9r, then 5.555 repeating minus 0.555 repeating, that's 5 minus 0 is 5. So 9r equals 5. To get r, we will divide both sides by 9. So that's equal to 5 divided by 9. So 9 divided by 9 is 1. So this is 1 here. 1r is equal to 5 over 9. So the answer is 5 over 9. So there is another way. We can directly answer using this way. Can directly answer what is the equivalent fraction form of 0.55 repeating. And that is, we need to determine if it's a repeating decimal. So this bar here means that the number 5 is being repeated. So 5 here is in the tens place. So we'll put 5 as our numerator, and over this is the tens place. So 10, we will subtract 1, so that is 9. So that's 5 over 9. Let's A pizza is divided into 8 equal slices. Direct 8 1/4 of 1/2 of the pizza. What part of the whole pizza did direct 8? Is it A, 1/8, B, 1/6, C, 1/16, D, 1/20? I'll give you 5 seconds. Timer starts now. Okay, time is up. And the correct answer is letter A, 1/8. How did we get the answer? So the problem states that a pizza is divided into 8 equal slices. So here 1, 2, 3, 4, 5, 6, 7, 8. And direct 8 1/4 of 1/2 of the pizza. So that 8 equal slices will divide it into half. So we have 4 parts, 1, 2, 3, and 4. And direct 8 1/4 of 1/2. So 1 part of half of the pizza. So that will be, what part of the whole pizza did direct 8? So the whole pizza, 1 part out of 8. So that's 1 out of 8. So 1/8. Okay, let's proceed to number 13. Quantity 1/5 divided by 1/4 times 1/2 can be simplified as A 1/5, B 3/6, C 3/5, D 2/5. I'll give you 5 seconds. And the correct answer is 2/5. How did we get the answer? So we have here 1/5 divided by 1/4 quantity times 1/2. So remember that the rule in dividing fractions is that you are going to copy the first number. This is now the dividend. And then proceed to multiplication and get the reciprocal. Or we will, our numerator here is 1, so we'll make it as our denominator. And 4 will be our numerator. Then proceed to multiplication process. That is 1 times 4 equals 4. 5 times 1 equals 5. So this is now the result, 4/5. And then this parenthesis here means we will multiply. So multiply 1/2 to 4/5. That is 4 times 1 is 4. 5 times 2 is 10. So we'll reduce divisible by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. So that's why the answer is 2/5. Number 14. What would be the difference when 1/3 is subtracted by 2/5? Is it A, 1/15, B, 3/15, C, 11/15, or D, 2/15? Timer starts now. The correct answer is letter A, 1/15. Here is now the solution. Let's say difference, it's subtraction. So 1/3 minus 2/5. So here we need to determine if it's similar or dissimilar. When we say similar fractions, we have the same denominators. But in this given, we have 3 and 5. So they have different denominators. So we'll get the LCD. How are we going to get the LCD? So we'll have here 5 and then 3. Write the multiples of 5. We have 5, 10, 15. And the multiples of 3 are 3, 6, 9, 12, and 15. So we have here now the least common multiple of 5 and 3 is 15. So this is now our LCD. So that is 15 divided by 3 is 5 times 1 is 5. 15 divided by 5 is 3 times 2 is 6. So we'll now subtract. 5 minus 6 is -1 all over 15. Copy 15. That's all. Thank you so much for watching.